Well, it's kind of unavoidable now that anybody that guessed Arbor Press on the first video series, you are absolutely correct. This is a very tiny Arbor Press. As you can see, it's about 2 inches tall and about 50 millimeters in height. This will not be a very difficult finish on this. We got to put a channel in here, a couple of screws for the cap, a cross hole for the spline, deck this off, put a fork in there, stick a fork in it, it's done. Deck this off, put the rotation hole in there so that the press can utilize the little index plate that I made. Clean off the bottom, put the mounting holes in, and for the most part, this is a beautiful casting, like virtually no inclusions on this. This is going to look great when it's all cleaned up and assembled. PM Research was kind enough to put their little logo on there, PMR, Arbor Press USA. Looking forward to doing this one. Let's press it up against the sander, take some of the lines off, not go crazy on it because it doesn't need it, and then mill it. Let's do it. The frame is inverted in my vise. I have a couple of spacer blocks on either side of the frame. It is inverted, like I said. Locating on as much of it as I can. The starting dimension on this particular piece is the thickness of this rear web, right there. So I need to take about 1/16 of an inch off the top where that gate is. The part is located in there square against the 1, 2, 3 block for vertical alignment. You got to trust something, so I'm going to trust the back of it to be a good starting reference point. Cut that down to the required dimension on the print, and maybe pop the holes in the bottom at the same time since I already have it in this orientation. Let's do it. Now, there are several reasons for the way I'm going to approach this. This is now pressed up against my stationary jaw, which I know is vertical. When I side mill this area right here, I know this area will be parallel to the bottom. I want to do the side hole before I do the top work. So I could hold it sideways, I could do it sideways, but I want that hole in first. And I just want to see this cleaned up. So doing it very gently, making sure it's secure, don't distort the frame, snug it up, side mill this, just to clean it up. Establishing the individual heights of these bosses is easy with it sitting vertically on the base milled surface. We just move it front to rear. This is not symmetrical. The back one is a little shorter than the front one, but knowing the center, indicate the inside of the vise, offset by the radius, move your dimension. Should have it no problem. Yeah. You know, I'm going to scare you here for a second and just let me pull this thing out of here and show you what I'm looking at. Running back and forth across these faces with a cutter, if this is positioned vertically, you have a very good chance, I'm going to open the vise and change this setup, of encountering those bosses right there. Look at it from behind. They are very close, but as you rotate the part, you can see the gap opens up underneath. So instead of it sitting on the parallels, I'm going to lean it back. Matter of fact, I'm going to take the parallels out and lean it back. All right. Now I have no concern about engaging this area right here, because from the side I have a whole lot more room. If you'll shimmer the nausea shot here for a second, I'll show you exactly what I'm talking about. Okay, see, as it leans back, it opens up. The closer you get to, all right, hang on a second, there we go. There, with the part leaning back, it gives you all the relief you want directly underneath it. With it rotated forward, you have a big chance of engaging these back corners. So be very aware of that. All right, enough with the nausea can. Here we go. Though you can't see it, the back is complete. The back is 218 from here to the back face, and then there's a collective distance here. So at this time, all I'm going to do is move the table, the diameter of the cutter, and then just use my digital to tell me how much I have to go to establish the width. If anybody doesn't understand what I just said, by all means, put it in the comment line below. I'm using my small fixture plate to do the cross hole, and to line it up on the fixture plate, I did it very much like I aligned the legs. Lock the fixture in the vise, use the stationary jaw as my registration point, parallel, and yep. The manufacturer semi-defective parallels, what can I say? It's supposed to be face down. Anyway, the little Arbor press body is pressed up against the parallel. The two clamps are holding it securely. I'm going to rotate this 90 degrees so I can drill and ream that hole right there. As you may have seen me do in the past, I am using a gauge pin to visually align to the boss on the casting, and I'm going to work back from there. Part is clamped to my fixture plate. There's a parallel underneath the part to align it horizontally. And it's just a matter of drill and ream, and maybe take a little bit off the front at the same time. It is the pitch diameter of the pinion that is important to the rack. So if this doesn't slide right in there beautifully, this is about a size on size, but I want this to slip in there just ever so perfectly. I'm going to dust the OD of this rack. Try again. And when I say dusted, I mean a 1/2 thousandth or less coming off of there. I'm going to side mill the face of this right here. Knowing where the center of that is, this is a very critical face, and so is the depth of the slot that goes in there. Okay, now I know I have demonstrated this technique before, but this is really important for you guys to get a hold of. If you don't have a solid grasp on this, this is a very valuable, very quick way to come up with dimensions on parts, sizes, locations. It is very helpful. Right now, the spindle of this machine is located directly over the center of that hole. I changed from a drill chuck and I put in the end mill that I want to use to machine off this face. Knowing the diameter of the end mill, I can move the cutter, I can move the table, the radius of that cutter. That's a 250 cutter. I'm going to move the table 125 to the right. And it really doesn't matter what the diameter is. You're only going to move the radius. Okay, so if that's a 10 millimeter cutter, move the table 5 millimeters and watch what happens. I always go clockwise with my dial, so you're always going to see me come back to it. Okay, right now the edge of the cutter is over the center of the hole. So if the dimension on the part is from the center to a plane or to a location, this is how you establish that. I'm going to re-zero my digital right now. My digital is now going to give me the distance from the center of that hole to that face in real numbers. So if I shift over here, my digital is now sitting on 191. The resultant feature should be 191 from the center of that hole to the edge of that cutter. Consequently, the center of the hole to the feature that it forms is also going to be the 191. I'm looking for 172 here. I am going to stay above that because anything below that may pinch the rack that goes through here. But learn that trick. Learn how to offset your cutter, the radius of the cutter, find the center of whatever it is you were on, and just shift over and let the digital do the work for you. Incredibly valuable. Let's cut the face. That face should now be exactly what was on my digital. The digital says 175. I'm trying to stay 0.03 of an inch or just less than 1/10 of a millimeter away from the plane dimension that it gives me. Too much material on this face is a good thing. It will increase the gap between the rack and the little pinion drive. It'll result in a little bit more slop in the handle, but that's better than too much tension on it and pinching it. I'm going to line up my y-axis by indicating the slot that I put in the previous operation. 0 on that side, and this is overkill. This does not need to be indicated, and believe it or not, that is a little over a couple of tenths past, and a couple of tenths past. This is the area that really needs to be lined up, so this for now is reference. There's no mating pieces between the top and the bottom. This is strictly visual. Let's take a look at the top. I think it's wiggler time. Do yourself a favor, if you have one of these spring-loaded friction wigglers, don't adjust it by hand. If it ever gets away from you, it's going to cut you up and laugh and keep on going. Use something long and just stabilize it that way. Just like that. Could you imagine this thing coming around on your knuckles? It's time to dial 911 or get someone to take you to the hospital. little movement, but I'm okay with that. I'm going to zero off on the bottom, usually zero off on the top. Use my centerline feature on my digital and find the middle. Could also tram the pin, but that's not the visual. Once you put the plate on there, if the plate overlaps one end or the other, it's going to stick out like a sore thumb. And that is, in fact, the center of my world right there. For reference, I'm going to check the y-axis alignment just for laughs. My eye, it's 2 thousandths out. Close enough. And yes, off camera, I ran an indicator across the tip of this to make sure that it was true to the world. For anybody that's going to say, what's up? Well, for sure, if you have any wear on your end mill, this is an application where you're going to feel it. And this situation is a perfect example of that. The fit is beautiful until about the last 20 thousandths of an inch on that channel. And to me, that doesn't mean open up the channel. That means change the end mill. If the top is good, that means that wherever this was used last was probably used in steel. And the bottom incremental depth area on that cutter is slightly less. Quick look at the finished machine base. All nice and cleaned up. If I had any suggestions for anybody listening that may or may not work at the company or own one of these kits and plan to build it, I would put 2 clearance holes in the bottom so the screws holding the tray to the legs can come through the tray and not worry about interfering with this. You wouldn't have to shorten the screws. When it's in this orientation, just drill 2 extra holes in it. Blind holes, of course, don't pop through, but that would allow those screws to come through. All right, let's grab all the parts, put this thing together. All right, you will find on the instructions at the assembly level, it tells you to adjust the height of these screws so they don't interfere with that face right there. Well, I don't feel like burning my fingers, so I knocked out a couple of washers real quick that I'm going to put underneath to keep that protrusion from happening. I did the same thing with the screws going through the side of the main body of this press. Just for decorative purposes. We've got a couple of brass screws hanging on there too. Okay, let's start by assembling the tray. I got to take the tray off, put these screws through these washers, reinstall them, and then we can start making this look like something. Okay, let's put this guy together. Now, the one thing I would like you to really appreciate and forgive me for is the camera angle. This camera is currently on a tripod sitting on the floor, but the ideal angle is if the camera was hanging off of my toolbox. And that's just not possible at the moment. So we're going to put the screws on the tray mount that keeps the screws from passing through and hitting the bottom of the main body of the press. This is accelerated footage, and you can see the screws are now flush. And another close-up on my wrist. Sorry about that, guys. Pushing on the back of the press so that the screws keep it parallel to the sides of the tray. All good. Well, here comes the handle on the side. This is a brass handle and easily distorted. If you're going to do this, please be careful. If you hit this too hard, you will bend that rod, and, well, I mean, it'll look real, but it'll be bent. To me, that's unacceptable, so be careful. Make sure that it floats freely. Make sure that the spline still floats through the casting. Put the retainer washer on the other side. Tighten it down. Looks an awful lot like a real press at this time. The gear rack, gravity is not your friend. Make sure that you position this so that the gravity will not do this again. Wait a minute, it's coming, wait for it. Oh, there it is. All right, we're done. Lay it down. Evolve, right? Work smart, not hard. Here comes the little brass plate that I did with the aluminum inserts. This is why the brass plate had to be symmetrical. This is why the tapped holes had to be symmetrical. It's incredibly visible. Putting this on, snugging this up, this thing is basically done. Keep your fingers crossed. When you crank that little handle, everything moves. Let's take a look. You know, as simple as this build was, as far as components are concerned, put yourself 100% into every piece that you make. I don't care if it's a washer, a highly visible frame, legs, tray, it doesn't matter. When you're done, you're going to be proud that the effort that you put into it is just going to reward you forever. So there is no insignificant part on a piece this small. Nothing. Thank you very much for watching. Joe Pye here at Advanced Innovations in Austin, Texas. I'm out.